This is the next lesson for geometry. It's Unit 4 Congruence, and this is our third lesson in the unit. The lesson is called Proving Congruence, Angle, Side, Angle, and Angle, Angle, Side. Okay. So at the beginning of this unit, we learned about congruent triangles having to show the 6 corresponding parts congruent. And then we did 2 shortcuts already. We did side, 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 and we did side, angle, side. Now we are going to do 2 more shortcuts, which are labeled in the lesson title. Okay. The first shortcut we're going to do today is angle, side, angle, or ASA for short. Okay. So if 2 sides and the included side, if 2 angles and the included side, meaning the side in between the 2 angles. So if I'm talking about angle T and angle R, the included side is the side TR. That would be the included side. Okay, so if 2 angles and the included side of one triangle are congruent to 2 angles and the included side of another triangle, then the 2 triangles are congruent by angle, side, angle. And again, the order matters. So if you say triangle RTW, 2 arcs, 1 arc, no arcs, that's congruent to 2 arcs, 1 arc, no arc. So triangle RTW is congruent to triangle CGH, okay, by angle, included side, angle. Angle, included side, angle. Has to be the included side. So let's do one proof on that. Given that CP bisects angle BCR and angle BPR, prove that triangle BCP is congruent to triangle RCP. So statement 1 is my given, reason 1 is given. So CP bisects angle BCR and angle BPR, reason 1 is given. Let's start with the first one. CP bisects angle BCR. So angle BCR is bisected, which means this half is congruent to this half. So for statement 2, I'm going to use three letters when I name each angle. I'll say angle BCP is congruent to angle RCP. I'll say definition of angle bisector. Okay. And then we have CP bisects angle BPR. So angle BPR is bisected. So this half or this angle is congruent to this half or this angle. So I'm going to say angle BPC angle BPC is congruent to angle RPC. Again, that's the definition of angle bisector. Because it's an angle bisector, it cuts the angle into 2 congruent angles. If you want to combine those into one step because it's the same reason, that's fine. Then you'll use just 4 steps in this proof. But coming up next, we got the reflexive property of congruence. I'm going to say CP is congruent to CP. Don't forget the segment symbol. Reflexive property of congruence. And now I can say that triangle BCP is congruent to triangle RCP. And that goes angle, side, angle, angle, side, angle. So angle, side, angle. Obviously, because that was the one we just did on this page. So angle, side, angle. Okay, let's move on to the next page. We have one more shortcut. This one is angle, angle, side. If 2 angles and a non-included side of one triangle are congruent to the two corresponding angles and a non-included side of a second triangle, then the two triangles are congruent by angle, angle, side, AAS for short. So you see in this diagram, you have this angle congruent to this angle. You have angle K congruent to angle A, and you have a non-included side congruent to another non-included side. So this goes angle, angle, side, angle, angle, side. So our four shortcuts, side, 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 and side, angle, side from the last lesson. In this lesson, we have angle, side, angle, and angle, angle, side. Let's do one proof on that. Okay, so we have two given informations. Those for statement one. Angle V is congruent to angle S, and segment TV is congruent to segment QS. Reason one is it was given. Now, if your diagram is not labeled, you'd want to label that now, but this one's already labeled. Next up, we are going to use the vertical angle there. I'm going to say, I'll put two arcs on this angle, and I'll put two arcs on this angle. So you can name them however you want. I'll just go with angle 1 is congruent to angle 2. Vertical angle theorem. THM for short for theorem. And now I can say that triangle TRV, or TVR I should say, because that's the way it says in the problem. Triangle TVR is congruent to triangle QSR. And the reason, obviously it's the one right above this, but it goes angle, angle, side, angle, angle, side, because it's not the included side. Okay? If it was the included side, you'd say angle, side, angle. But this one is not the included side, so angle, angle, side, angle, angle, side, angle, angle, side. If you want to pause the video and read through this, you can. Or you can just look at my notes online. But this just summarizes the four shortcuts to prove triangle congruence. Side, 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 and side, angle, side was from the last lesson. And angle, side, angle, and angle, angle, side are this lesson. So either pause the video if you want to read through this, or just look at my notes that are posted online. Okay. Here's a multiple choice question you could see on the SAT. For the triangle shown, angle D is congruent to angle T, angle E is congruent to angle U, and segment EO is congruent to segment UX. Which of the following statements is true? Why don't we just label them? Might as well just label them. D and T, one arc on each. E and U, one arc on each. And then EO is congruent to UX. So first of all, the reason why the triangles are congruent is we have angle, angle, side, angle, angle, side. So it means it's not A, and it's not C. So it's either B or D. Okay. T corresponds with D. So it's got to be D. T corresponds with D. In the second, in part B, it doesn't. T is second, D is first. T corresponds with D. Okay, that's good. Let's just double check the rest. U, two arcs, corresponds with E, two arcs, so U and E good. And X corresponds with O, third angle theorem. Anyway, the answer is D. That's how you can make that conclusion. Okay. Example 4. State what additional information is required in order to know that the triangles are congruent for the given reason. Example 4A, angle, side, angle. Well, you know this side is congruent to itself. We don't need to be told that. In order for these two triangles to be congruent by angle, side, angle, it has to be the included side, meaning you need this angle with the star to be congruent to this other angle with the star. That's what you need. If you have these two angles with the stars labeled being congruent, then it would go angle, side, angle, angle, side, angle. So you need the starred angles being congruent. And so I'm going to name those with 3 letters, but we need angle QSD congruent to angle ECD. If we knew that, then we'd have enough for angle, side, angle, because we know this side is congruent to itself. Part B, angle, angle, side. Well, we know this side is in common to both, so we do not need that. But in order to have angle, angle, side, you need this angle with the star congruent to that angle with the star, not the other ones, because if you had these, then you'd have angle, side, angle, okay? If you had this angle, I'm just going to use one arc just for now. Suppose you knew this angle was congruent to this angle. That would be angle, side, angle, because it's the included side. So that's not the answer. You need to know that angle E is congruent to angle T. That's what you need. Because if you had that, then you'd have angle, angle, side, angle, angle, side. Part C, what other information do you need to have angle, side, angle? Well, you have vertical angles. You can label that yourself. You do not need that, so we know that. So what do we need for angle, side, angle? We need to know that this side with the star is congruent to that side with the star. Okay, so you need WV congruent to KV. If you had that, then you would have angle, side, angle, angle, side, angle. So that's what you need. Okay. Move on to the next page. CPCTC is an acronym that we use in geometry. I think I mentioned this very briefly in the past. CPCTC is an acronym. It stands for the following. Okay, CPCTC stands for the following: corresponding parts of congruent triangles are congruent. CPCTC stands for corresponding parts of congruent triangles are congruent. This goes back to the first lesson. Once you know you have congruent triangles, then you can say all the corresponding parts are congruent. So you can say all 6 corresponding parts are congruent. Okay? CPCTC is a justification or a reason that we are going to be using in proofs once we have proven the 2 triangles are congruent. Okay? So keep in mind, you use side, 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 angle, side, angle, side, angle, 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 side, and hypotenuse, leg, which is the last shortcut, which we're going to do next class, I believe. So we haven't done that one yet. But these are the 5 reasons you use when you want to say 2 triangles are congruent. Think back to the last 2 lessons. Whenever you want to prove 2 triangles are congruent, you always end with one of these justifications: side, 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 angle, side, and so on. Okay? If you want to say that a certain part of a triangle is congruent to a part of another triangle, that's when you use CPCTC. Okay? You use that after you already have triangles congruent, and you want to say that a certain part is congruent to a certain part. Okay? So let's see that in action for example 5. Okay. Given YW bisects segment XZ and segment XY is congruent to segment ZY. Let's label that already. XY is congruent to ZY. So those will be my given statements. YW bisects XZ, and then XY is congruent to ZY. Reason 1 is because that was given to you. Okay. Now you want to prove that angle XYW, that angle up top, is congruent to angle ZYW, that other angle up top. The only way to do that is to first prove the two triangles congruent. So we need to prove that these two triangles are congruent. Then we can say that this angle is congruent to this angle by CPCTC. Okay, so YW bisects XZ. That means XZ is cut in half. So this half is congruent to that half. So I'm going to say that segment XW is congruent to segment ZW. That's the definition of a segment bisector. Definition of segment bisector. Then I'm going to use the reflexive property of congruence. I'm going to say that WY is congruent to WY. Reflexive property of congruence. And now I can say that the triangle on the left is congruent to the triangle on the right. So I can say that triangle, it's got to go in the right order. I'll do YXW, 1 tick mark, then 2, is congruent to segment YZW, 1 tick mark, then 2. That was side, side, side. And now, since I have the two triangles are congruent, I can say that all 6 corresponding parts are congruent. Think back to lesson 1 when we did that. But since I have the two triangles congruent, I can say all 6 corresponding parts are congruent. So I can say that angle XYW, that angle up top, is congruent to this angle up top, angle ZYW, because corresponding parts of congruent triangles are congruent. One more example. PR bisects angle QPS and PR bisects angle QRS. Prove that segment PQ is congruent to segment PS. So we're going to do the same process. You have to first prove the two triangles are congruent, and then you can say that segment PQ is congruent to segment PS because corresponding parts of congruent triangles are congruent, CPCTC. So reason 1 is both my givens. I'm just going to copy those both down. PR bisects angle QPS and PR bisects angle QRS. Reason 1 is given. Again, you might not always use the same number of steps as me in the proof. But step 2, I'm going to use the definition of an angle bisector. Since PR bisects angle QPS, it means QPS is cut in half, so this angle with one arc is congruent to this other angle with one arc. So I'll say angle QPR is congruent to angle SPR. Definition of angle bisector. And then angle QRS is also bisected. So angle QRS is bisected. So this angle with one arc, with 2 arcs, is congruent to this other angle with 2 arcs. So I'm going to say angle QRP is congruent to angle SRP. Again, you can combine steps 2 and 3 if you want because it's the same reason, but I just separated them. Definition of angle bisector. Then I'm going to use the reflexive property of congruence. I'm going to say that PR is congruent to PR. Reflexive property of congruence. Now you can say the two triangles are congruent because if you look, it goes angle, included side, angle. Angle, included side, angle. Just be careful for the order of the triangle congruent statement. I'll say triangle PRQ. So did one arc, then two arcs, then none, is congruent to triangle PRS. And again, like I just said, that was angle, side, angle. And since I know the two triangles are congruent, I can say all the corresponding parts are congruent. So we had to prove that PQ was congruent to PS, and I can say that because CPCTC, the corresponding parts of congruent triangles are congruent. Okay. And that is the end of that lesson. That was called proving congruence, angle, side, angle, and angle, angle, side. So we learned 2 new shortcuts today, and then we did some CPCTC proofs.